Look up at the night sky, really look, and tell me what you see. A scattering of stars, perhaps the faint glow of a distant planet. But what if I told you that every pinprick of light out there is part of something far grander, a cosmic tapestry woven across billions of years? Carl Sagan once said, "Somewhere, something incredible is waiting to be known," and that's precisely what we're here to explore. Welcome to Infinite Reflections, a meditative journey through the timeless wonders of the cosmos, where science and wonder collide in the most breathtaking ways. Picture this, the Hubble Deep Field, a single patch of sky no larger than a grain of sand held at arm's length. Yet within that tiny frame, thousands of galaxies swirl, each one a universe unto itself, teeming with stars, planets, and possibilities beyond our wildest imagination. This is the paradox of the cosmos, vast beyond comprehension, yet intimately connected to us all. We're not just observers of this grandeur, we're part of it, stardust given form, gazing back at the very forces that shaped us. What if we told you that the secrets of the universe aren't locked away in equations or distant telescopes, but are waiting to be uncovered through contemplation? This journey isn't just about black holes or nebulae, though we'll uncover their mysteries too. It's about something deeper, the way the cosmos mirrors our own search for meaning, how the birth of a star echoes the spark of human curiosity, and how the infinite expanse above us invites us to reflect on our place within it. So let's pause together and step into the unknown, because the universe isn't just out there, it's within us, calling us to look deeper, wonder louder, and lose ourselves in the beauty of the infinite. The night sky has always been more than just stars. It's a mirror reflecting humanity's oldest questions back at us. Think about the earliest civilizations, gazing upward and seeing gods, heroes, and omens written in constellations. To them, the heavens weren't just distant lights, they were a celestial storybook whispering secrets about fate and meaning. Fast forward to today, and we still look up with that same awe, but now we see something even more extraordinary. A cosmic laboratory where the laws of physics play out on scales we're only beginning to grasp. Neil deGrasse Tyson often speaks about how astronomy humbles and elevates us simultaneously. When we study the birth and death of stars, we're not just learning about nuclear fusion in far-off nebulae, we're piecing together the story of our own origins. Every atom in our bodies was forged in those stellar furnaces, meaning the universe isn't just around us, it is us, looking back at itself. That's the magic of this cosmic mirror. It shows us that the questions we ask about the stars are inescapably questions about ourselves. Consider the paradoxes woven into this reflection. We feel small under the infinite expanse, yet we're made of the same materials as the galaxies swirling overhead. We search for life beyond Earth while barely understanding the miracle of consciousness that lets us wonder at all. The cosmos doesn't just reflect light, it reflects our fears, hopes, and unshakable curiosity. And just when we think we've grasped its patterns, the universe reveals another layer of mystery, pulling us deeper into the unknown. Here's a truth that bends the mind. The universe stretches beyond imagination, yet it began at a single point. We call this the first great cosmic paradox, an existence without edges but with a birthday. The Big Bang wasn't an explosion in space, it was the birth of space itself, a moment when time flickered to life and everything we know, every galaxy, every atom, was compressed into a speck smaller than a single thought. Stephen Hawking once compared it to the surface of a balloon. As you blow air in, every point on that rubber stretches away from every other. There's no center, no outside, just expansion everywhere at once. Now here's where it gets even stranger. If the universe is nearly 14 billion years old and light travels at a fixed speed, then the farthest we can see is a sphere of light emitted from that ancient dawn. But what lies beyond that horizon? Is there more space forever repeating? Or does the very idea of beyond lose meaning? Scientists debate whether the cosmos is infinite like an endless ocean or finite like the surface of that balloon, looping back on itself in dimensions we can't perceive. And yet, the universe doesn't just expand, it accelerates, pushed by forces we've named dark energy without truly understanding them. It's as if the fabric of reality has a hidden engine, and we're only seeing the shadows it casts. This is the heart of the paradox. We're surrounded by infinity, but trapped in a bubble of perception, forever chasing the edges of a story that might have no end. The deeper we look, the more the cosmos asks us to rethink what it means to begin, to end, or to exist at all. We think of light as the great revealer, the force that shows us what's real, but what if the universe's deepest truths are hidden in the dark? Here's the staggering paradox. Everything we've ever seen, every star, every galaxy, every shimmering nebulum makes up less than 5% of existence. The rest is an invisible tapestry of dark matter and dark energy, cosmic ghosts that tug at the fabric of reality without ever showing their faces. It's as if we've been reading a novel and only just noticed the ink is outnumbered by the empty spaces between the words. Dark matter is the universe's silent architect. Though we can't see it, we know it's there because galaxies spin faster than they should, held together by some unseen hand. Picture a merry-go-round whirling so fast its riders should fly off, but they don't because invisible ropes keep them anchored. That's dark matter, the ropes we can't see woven through the cosmos. Then there's dark energy, even stranger, a force that's not just holding things together but tearing them apart, pushing galaxies away from each other faster and faster, as if space itself has a hidden heartbeat. The James Webb Space Telescope recently offered us whispers of this shadow realm. Peering into the earliest moments after the Big Bang, it found galaxies so massive they shouldn't exist yet, their gravity defying our models. The only explanation, dark matter was there first, scaffolding the universe before light could catch up. It's a humbling reminder. Darkness isn't the absence of understanding, it's the canvas on which understanding is drawn. And isn't that how life works too? The most powerful forces, love, intuition, the pull of destiny, often leave no physical trace. We can't see gravity, yet it guides the planets. We can't measure a thought, yet it shapes civilizations. The universe, it seems, agrees. The invisible is not the insignificant. Which brings us to the most mesmerizing paradox of all. Black holes, where darkness doesn't just hide the universe's secrets, it consumes them. These cosmic voids are more than just traps for light. They're laboratories where space and time twist into knots, where the rules we know dissolve into something wilder, stranger. To stare into a black hole is to confront the ultimate question. How much of reality will always lie just beyond the edge of sight? Black holes are not the monsters of cosmic legend. They're the universe's most enigmatic artists, painting space-time itself into shapes we're only beginning to decipher. Picture the accretion disk, a swirling storm of superheated gas and dust, spiraling toward the event horizon at nearly the speed of light. It glows with the fury of a billion suns, not because the black hole is burning anything, but because the sheer force of friction and gravity turns matter into light. This is violence and elegance entwined, a dance where the laws of physics stretch to their breaking point. For decades, we imagined black holes as cosmic vacuum cleaners, sucking everything into oblivion. But Kip Thorne's groundbreaking work revealed something far stranger. According to his calculations, the extreme warping of space-time near a black hole could theoretically create wormholes, tunnels through the fabric of reality. Time dilation near the event horizon means minutes for you could be centuries for the outside world. It's not just destruction, it's transformation, a place where the universe folds in on itself like a page torn from a sci-fi novel. Then, in 2019, humanity saw the unseeable, the first image of a black hole's shadow captured by the Event Horizon Telescope, that glowing ring of light. That's the accretion disk bending around the event horizon, a visual echo of space-time itself twisting into a knot. The image confirmed Einstein's predictions with eerie precision, but it also left us with new questions. Why is the ring brighter on one side? What secrets lurk in the chaotic magnetic fields just outside the point of no return? Now, let's take the ultimate thought experiment. Imagine falling into a black hole. At first, you'd feel nothing, just the eerie pull of tidal forces stretching you like taffy. But cross the event horizon and the rules change. To the outside universe, you'd appear frozen in time, your image redshifted into oblivion. Yet for you, time marches forward. Some theories suggest you might emerge somewhere, or someone else, a shred of your original form woven into the fabric of a new reality. Others say you'd be scrambled into pure energy, your atoms recycled into the cosmic symphony. This brings us to the delicate irony of creation. Black holes don't just take, they give. The jets of energy screaming from their poles seed galaxies with heavy elements. The chaos they unleash can trigger star birth in their wake. Even Hawking radiation, the faint glow of particles escaping a black hole's grip, hints at a universe where endings are just another kind of beginning. So the next time you look up, remember, the darkest corners of space might just be where the light of understanding shines brightest. Deep in the heart of the Eagle Nebula, cosmic sculptures rise like ancient towers, the pillars of creation, where stardust becomes poetry. These colossal columns of gas and dust stretching light years high are more than just a celestial landmark. They're a nursery, a place where gravity and chaos conspire to ignite new suns. Imagine a cloud so vast it could cradle 1,000 solar systems, yet so delicate that the light of newborn stars within it could blow it apart like dandelion seeds in the wind. Astrophysicist Michelle Thaler describes these regions as the universe's way of turning emptiness into fire, where the coldest, darkest pockets of space become the birthplaces of light itself. Here's how the magic unfolds. Inside these nebulae, pockets of gas grow dense, pulled together by gravity's invisible hand. As they collapse, temperatures soar first by friction, then by the nuclear fires sparking in their cores. It's a battle between forces. Gravity compresses while the energy of fusion pushes back, and for a brief, fragile moment, equilibrium is born. A star flickers to life. But not all seeds survive. Some regions fragment into clusters, sibling stars born from the same cloud, while others are torn apart by stellar winds or the shockwaves of nearby supernova. The pillars of creation, for all their beauty, are a testament to this duality, both cradle and battlefield. Now contrast this delicate dance with the fury of a supernova, the death throes of a massive star. In its final moments, it unleashes enough energy to outshine entire galaxies, scattering heavy elements like cosmic confetti across the void. Iron from your blood, calcium in your bones, these were forged in such explosions, then swept up by nebulae to be woven into new stars, new planets, new life. It's a cycle of destruction and creation so intertwined that, as Thaler puts it, every ending here is just a different kind of beginning, which brings us to the quiet miracle of stars like our sun. Not too massive, not too small, a golden balance that allows it to burn steadily for billions of years, cradling planets in its warmth. The heavier elements it carries, carbon, oxygen, nitrogen, are the very ingredients of life, recycled from generations of stars that lived and died before our solar system even existed. So when you gaze at the night sky, remember, you're not just looking at points of light. You're seeing the factories that built you, the ancestors of every atom in your body, still glowing in the dark. Joni Mitchell sang it best, "We are stardust." At first glance, it sounds like poetry, but it's cutting-edge astrophysics. Every atom in your body, from the calcium in your bones to the iron in your blood, was forged in the heart of a dying star. Think about that for a moment. The oxygen you're breathing right now, it was once part of a supernova's final, cataclysmic breath, blasted across the cosmos billions of years before Earth even existed. Let's break down the alchemy. Inside stars like our Sun, hydrogen atoms fuse under unimaginable pressure, creating helium and releasing the energy that lights the universe. But for heavier elements, the recipe requires a more violent kitchen. When massive stars near the end of their lives, their cores become layered like an onion. Helium fuses into carbon, carbon into oxygen, and so on, all the way up to iron. Then, in a final act of cosmic defiance, the star collapses under its own weight and explodes in a supernova. That explosion is so powerful it forges elements even heavier than iron, gold, uranium, the very materials that make up our planet and our bodies. Now, here's the twist. Those elements don't just vanish into the void. Supernovae scatter them like cosmic seeds, mixing with interstellar gas until gravity pulls them into new stars, new planets, and eventually you. The carbon in your DNA, the nitrogen in your cells, even the zinc in your fingernails, all of it was recycled through generations of stars. You're not just observing the universe, you're carrying pieces of its history inside you. This revelation bridges science and philosophy in the most profound way. If we're made of stardust, then so is every other living thing, and every potential life form out there in the cosmos. That's why the search for extraterrestrial life isn't just about curiosity, it's a quest to meet our cosmic cousins. Astronomers now scan exoplanet atmospheres for traces of oxygen or methane, not just because those gases could hint at life, but because they're the same elemental building blocks that made us. Consider the implications. On a planet orbiting a distant star, another version of this alchemy could be unfolding. Maybe somewhere right now, carbon atoms forged in a long-dead star are linking into molecules, forming the first whispers of life. The universe has already proven it can turn stardust into thinkers, dreamers, explorers. Who's to say it hasn't done so again? The elements are the same. The laws are the same. The only question left is, are we alone in this vast starlit workshop? Or is the cosmos humming with other voices, other stories waiting to be heard? The universe is vast beyond imagination, trillions of galaxies, each with billions of stars, countless planets spinning in the dark. With numbers so staggering, the math seems undeniable. Life must be out there. So where is everybody? That's the haunting question physicist Enrico Fermi asked over half a century ago, and it still echoes through every silent corner of space. The Fermi Paradox isn't just about aliens. It's a mirror held up to our assumptions, forcing us to confront the eerie quiet where we expected a cosmic chorus. Take the Drake equation, a formula that tries to quantify our odds of finding neighbors among the stars. It multiplies factors like the rate of star formation, the fraction of planets that could support life, and the chance of intelligence evolving. Plug in optimistic numbers, and the galaxy should be teeming with civilizations. Yet after decades of listening, radio telescopes sweeping the skies, probes scouring Mars, algorithms sifting through static, we've heard nothing but the universe's indifferent hum. But silence isn't emptiness. Recent discoveries have rewritten the script. telescopes like Kepler and TESS have revealed thousands of exoplanets, many nestled in the Goldilocks zone, not too hot, not too cold, just right for liquid water. Some, like those orbiting TRAPPIST-1, are rocky worlds with atmospheres that could harbor the chemistry of life. Others, like K218b, hint at water vapor in their skies. These aren't just dots on a star chart. They're proof that the ingredients for life are scattered everywhere. So why haven't we found the cooks? One answer lies in the fragility of time. Civilizations might rise and fall like waves, their signals vanishing into the cosmic background before we can tune in. Or perhaps we're searching wrong, looking for radio waves when advanced societies have moved to technologies we can't yet detect. There's a darker possibility, too. That intelligence carries the seeds of its own destruction, a filter that stops civilizations from reaching the stars. But here's the most humbling thought of all. What if consciousness isn't inevitable? What if the leap from chemistry to curiosity is so improbable that we're the universe's first attempt, or its only one? The atoms that built us are common, but the spark that lets us ponder them might be rarer than a diamond in a desert. That's the paradox's sharpest edge. The cosmos may be infinite, but the thing we're searching for could be the rarest wonder of all. And if that's true, then every moment we spend gazing upward isn't just a search for others, it's a celebration of the improbable light we carry within us. What if the universe didn't just create life, it needed to? This is the spine-tingling premise of the Anthropic Principle, the observation that the laws of physics appear perfectly calibrated to allow our existence. Tweak gravity by a fraction or adjust the strength of the nuclear forces, and stars wouldn't ignite, atoms wouldn't bond, and life as we know it would be impossible. It's as if the cosmos filled out 1,000,000 lottery tickets, and we're the one that hit the jackpot. Philosopher Nick Bostrom takes this further, suggesting an even wilder possibility, that we're living in a simulation, an elaborate construct where the rules were coded to produce conscious observers. Whether or not you buy that theory, it forces a profound question: is human awareness the universe's way of waking up to itself? Consider the carbon atom, so vital to life. Its existence hinges on a bizarre cosmic coincidence. Inside stars, 3 helium nuclei must collide nearly simultaneously to form carbon, a statistical long shot. Yet, as physicist Fred Hoyle realized, there's a resonance in carbon's energy levels that makes this unlikely reaction staggeringly efficient. Without this precise tuning, the building blocks of life wouldn't exist. Hoyle later admitted it felt like a put-up job, as if some higher logic had stacked the deck. This fine-tuning extends to the very fabric of reality. Dark energy's repulsive force, for example, is exquisitely balanced, strong enough to push galaxies apart, but weak enough to let gravity form stars. If it were slightly stronger, the universe would have blown itself apart before life could emerge. Slightly weaker, and everything would have collapsed back into a black hole. The odds against this balance are astronomical, leading some scientists to propose a multiverse, a sea of universes with random constants, where we simply inhabit the one that got lucky. But here's the twist: our cosmic home is far more fragile than we think. A single rogue asteroid, a gamma ray burst from a nearby star, or the slow death of our sun could erase everything we've built. Earth orbits in a precarious bubble of habitability, a tiny oasis in a desert of cosmic extremes. That fragility makes consciousness even more remarkable. For a fleeting moment, the universe has crafted something that can wonder about its origins, mourn its inevitable end, and dream of touching the stars. Whether we're alone or not, that spark of awareness might be the rarest jewel in the cosmos, a flicker of light in the dark, asking, "Why am I here?" Carl Sagan's voice still echoes across the decades, soft yet urgent, as footage of Earth floats on screen, a single pixel in a sunbeam suspended in the black. "Look again at that dot," he whispers. "That's here, that's home." The pale blue dot image captured by Voyager 1 from 4 billion miles away isn't just a photograph. It's a reckoning, our entire history, every war, every love story, every whispered prayer unspooled on a speck smaller than a dust mote in the cosmic ocean. And yet that fragile dot is all we've ever known. Now zoom in. Watch the swirl of hurricanes from orbit, the creeping blush of wildfires scarring continents, the delicate veil of atmosphere thinner than an apple's skin. Climate change isn't just an Earth problem, it's a cosmic one. We're the first generation to see our planet whole, and the last with a chance to keep it habitable. Astronauts call it the overview effect, that visceral shift in perspective when you see Earth without borders, a living mosaic of clouds and oceans, fragile and furious all at once. Rusty Schweickart, Apollo 9 astronaut, described it as realizing, "You're not there on the planet, you're of it. Yet down here, we still fracture over lines drawn in sand." Wars over resources that from space seem laughably scarce, pollution choking the very air that from the moon appears as a wisp of blue. The irony stings. We're a species smart enough to decode the universe's laws, but still struggling to share a speck of rock adrift in the void. But here's the hope hidden in that paradox. The same tools that let us glimpse our planet's vulnerability also let us reach beyond it. Telescopes like Hubble and Webb aren't just windows to the stars, they're mirrors reflecting back our responsibility. Probes like Voyager and Perseverance aren't just explorers, they're lifelines teaching us how to sustain life in hostile worlds so we might one day heal our own. Every rover on Mars, every satellite mapping deforestation, every algorithm predicting storms is a stitch in the safety net we're weaving for our pale blue home. So the next time you feel small under the night sky, remember, the cosmos doesn't diminish us, it connects us. That dot isn't just where we're from, it's who we are. And the universe, vast as it is, has given us something rare and precious, each other, and a chance to keep the light burning just a little longer. A telescope isn't just a window to the stars, it's a time machine. Every photon that lands on Hubble's mirror or grazes the gold-plated hexagons of the James Webb Space Telescope carries ancient stories, some so old they predate Earth itself. When you look at the galaxy GNZ 11, shimmering 13 billion light-years away, you're not seeing it as it is today. You're witnessing its infancy, a snapshot from when the universe was a mere toddler, just 400 million years old. That faint glow spent longer crossing the cosmos than atoms took to form your bones, your breath, your very consciousness. Think of it like flipping through a family album where each page reveals ancestors you've never met. The Andromeda Galaxy, that's your great-grandparent, a portrait from 2.5 million years ago, when early humans were just discovering fire. The Sombrero Galaxy, a relic from 30 million years past when mammals were reclaiming the Earth after dinosaurs fell. And the deeper we look, the further back we reach, like peeling layers off an infinite onion, each revealing a younger, wilder universe. But here's what makes this cosmic archaeology possible: light's relentless speed. It's both messenger and historian, delivering news from the past at 300,000 kilometers per second. The James Webb Telescope pushes this to the extreme, capturing infrared light stretched by the universe's expansion, revealing galaxies so distant their light arrives as faint whispers. In 2022, Webb shattered records by spotting galaxies born less than 300 million years after the Big Bang, structures so mature they defy expectations, like finding a skyscraper in the Stone Age. Now imagine standing under a starry sky, knowing some of those pinpricks might already be dead. Betelgeuse, the red giant in Orion's shoulder, could have gone supernova centuries ago. We just haven't seen the light yet. Telescopes don't just show us where things are, they reveal when they were, turning the night into a mosaic of different epochs. This yearning to touch the stars isn't new. Ancient Polynesians navigated by them, Galileo sketched Jupiter's moons, and today, probes like Voyager carry golden records into the void. But telescopes offer something even interstellar travel can't, a way to hold the universe's entire history in a single gaze. Every observation is a bridge across time, stitching together the story of how swirling gas became galaxies, then stars, then us. And as we keep looking deeper, farther, we're not just searching for origins. We're chasing the echoes of our own becoming. Humanity's dream of reaching the stars is as old as our first stories, but will it ever be more than a dream? The closest star system, Alpha Centauri, sits 4.3 light-years away. At today's rocket speeds, that's a 70,000-year journey. Even Pluto, in our own solar backyard, took NASA, a New Horizons probe, 9 years to reach. The numbers seem to crush hope before we even begin. Yet beneath these sobering realities lies a tapestry of ingenuity, where scientists and visionaries are rewriting the rules of what's possible. Take propulsion. Chemical rockets, the workhorses of our space age, are hopelessly slow for interstellar travel. Their fuel is heavy, their exhaust velocities a snail's pace compared to light. But alternatives are already on the drawing board. Nuclear propulsion, harnessing the energy of splitting atoms, could slash travel times to Mars from months to weeks. Project Orion, a Cold War-era concept, even imagined spacecraft riding the shockwaves of nuclear explosions, an idea too wild for its time, but one that hints at humanity's willingness to think radically. Then there's light. Breakthrough Starshot, backed by Stephen Hawking and Yuri Milner, proposes sending gram-scale probes to Alpha Centauri propelled by giant Earth-based lasers. These nanocraft, equipped with cameras and sensors, would ride beams of light like microscopic sails, reaching 20% the speed of light, arriving in just 20 years. It sounds like science fiction, but the physics checks out. The catch, building a laser array the size of Manhattan, ensuring the probes survive decades of space dust impacts, and figuring out how to transmit data back across 4.3 light-years of void. But what if speed isn't the answer? Generational ships offer another path, vast arcs where entire civilizations live and die during the centuries-long voyage. Biospheres would recycle air and water, while onboard societies evolve in isolation. Arthur C. Clarke once mused that such ships might become the pyramids of the future, monuments to patience rather than speed. The ethics are thorny. Is it fair to condemn unborn generations to life in a metal womb? Yet the idea endures because it acknowledges a profound truth. The universe operates on timescales far beyond human lifespans, and if we're serious about the stars, we must think in centuries, not election cycles. Which brings us to the quieter revolution unfolding in our own solar system. While we dream of Alpha Centauri, probes like Europa Clipper and Dragonfly are peeling back the mysteries of icy moons and alien atmospheres right here at home. Saturn's moon Titan, with its methane lakes and organic-rich dunes, might hold clues about life's origins. Jupiter's Europa, with its hidden ocean, could be the closest thing to an interstellar oasis we'll find for generations. The lesson is clear: the cosmos doesn't hand us shortcuts, but every time we land a rover on Mars or peer through Europa's icy crust, we're rehearsing for the day when the stars finally come within reach. So is interstellar travel fantasy, not if you define it by the laws of physics rather than the limits of politics or funding. The challenges are Everest-sized, but so was the moon landing before 1969. What's missing isn't technology or imagination, it's the collective will to treat space not as a destination, but as a destiny. As Clarke famously said, the only way to discover the limits of the possible is to go beyond them into the impossible. The stars aren't waiting for us to be ready, they're just waiting for us to dare. Beneath the frozen crusts of Europa and Enceladus, entire oceans churn in perpetual darkness. Liquid water trapped between ice and rock, kept warm by the gravitational tug-of-war of their parent planets. These aren't just moons, they're locked treasure chests hiding more liquid water than all of Earth's seas combined. Europa, Jupiter's enigmatic child, wears its scars like a road map, cracks and ridges spiderwebbing across its surface, hinting at the sloshing abyss below. Enceladus, Saturn's sparkling secret, goes a step further, spitting geysers of water vapor and organic molecules into space through fractures near its south pole, as if shouting, "Look closer." NASA Europa Clipper mission, set to launch in 2024, is humanity's answer to that cosmic invitation. Unlike landers that drill or dig, Clipper will perform a meticulous dance, skimming just 25 kilometers above Europa's surface to taste the plumes erupting from its icy shell. Its instruments will analyze the chemistry of those ejected particles, hunting for amino acids, lipids, any whisper of the building blocks of life, but the real prize. Mapping the thickness of Europa's ice to pinpoint where future missions might one day pierce through to the ocean itself. Imagine a robotic submersible melting its way downward until it reaches liquid water untouched by sunlight for billions of years, exploring an alien sea lit only by the faint glow of hydrothermal vents. Here's where Earth's extremophiles rewrite our expectations. In our planet's most hostile corners, boiling sulfuric acid pools, crushing ocean trenches, even inside nuclear reactors, life thrives. Microbes called Deinococcus radiodurans can survive radiation doses 1,000 times lethal to humans. Tardigrades, those microscopic water bears, endure the vacuum of space. If life can cling to existence in these extremes, why not in Europa's dark ocean, where warmth and minerals spew from volcanic vents? The energy source might not be sunlight, but chemistry, hydrogen and carbon dioxide reacting to form methane, just as they do around Earth's deep-sea hydrothermal vents. Yet Europa and Enceladus aren't merely potential homes for life, they're cosmic paradoxes. How can moons so small, so far from the sun, maintain subsurface oceans for eons? The answer lies in tidal heating, a gravitational waltz that stretches and compresses their interiors. Jupiter's immense pull flexes Europa like a ball of clay, generating enough heat to keep its ocean liquid. Saturn's gravity does the same to Enceladus, its icy shell acting like an insulating blanket over a simmering pot. These moons defy the old rules of habitability, proving that life's playground might be vaster and stranger than we ever imagined. Which leads us to an even deeper mystery. If life exists in these shadowed oceans, could it resemble Earth's, or would it follow an entirely different blueprint? Silicon instead of carbon, ammonia instead of water, Europa and Enceladus challenge us to rethink the very definition of alive. And as we stand on the brink of exploring these hidden worlds, we're not just searching for aliens, we're uncovering the universe's quiet defiance of the ordinary, where even the coldest, darkest corners might hum with the pulse of something extraordinary. Einstein called it spooky action at a distance, a phrase that captures both the wonder and unease of quantum entanglement. Picture two particles born from the same event, separated by light years, yet still mysteriously linked. Change the spin of one and the other instantly responds, as if space and time between them don't exist. This isn't science fiction. It's a fundamental feature of our universe, proven repeatedly in labs. In 2017, scientists even used photons from distant quasars to test entanglement, letting the cosmos itself choose the measurements, and the particles still danced in perfect, inexplicable sync. Einstein hated this idea. To him, physics was about locality and certainty, not dice rolls and instantaneous connections across the void. His famous debates with Niels Bohr revolved around this tension. Does the universe operate on hidden variables we haven't discovered, or is uncertainty baked into reality itself? Bohr's Copenhagen interpretation embraced the weirdness, suggesting particles exist in probabilities until observed, a concept that still bends minds today. But here's where it gets cosmic. Entanglement isn't just a lab curiosity. It might be the glue holding space-time together. Some theories suggest that the fabric of the universe is woven from countless entangled particles, their connections forming the geometry of reality. Black holes could stretch these quantum threads to their limits, creating wormholes or even new dimensions. It's as if the universe runs on a hidden code, and entanglement is its encryption key. Which brings us to mathematics, the silent language of this cosmic symphony. From Newton's calculus to Schrödinger's equations, math doesn't just describe the universe, it predicts phenomena we haven't even observed yet. Take Dirac's work. His equations predicted antimatter before anyone had seen it. Or Einstein's field equations, which foresaw black holes decades before telescopes could spot them. The numbers aren't just tools, they're portals revealing layers of reality our senses could never grasp. So when we talk about quantum weirdness, we're not just peering into the atom's heart, we're touching the blueprint of existence itself. The universe doesn't owe us intuitive explanations. It whispers in probabilities and entangled whispers, daring us to listen. Galileo once wrote that the universe is a grand book written in the language of mathematics, and every page since has proven him right. Take Einstein's iconic equation, E equals mc squared, just 5 symbols, yet it unravels the relationship between energy, mass, and the speed of light with breathtaking precision. This isn't just a formula, it's a key that unlocked nuclear power, revealed the fiery hearts of stars, and even explained how the sun keeps shining. The beauty of math lies in its silent power. No matter where you are in the cosmos, 2 + 2 = 4, and gravity bends light the same way in a distant galaxy as it does in our solar system. Now look closer, much closer. Zoom in on a snowflake's delicate branches, and you'll see patterns that echo the sprawling arms of spiral galaxies. These fractal designs repeat across scales, from the branching veins of a leaf to the jagged coastlines of continents, even down to the way lightning forks across the sky. The Mandelbrot set, a mathematical fractal, reveals infinite complexity no matter how deep you dive, a visual echo of nature's obsession with recursion. It's as if the universe has a favorite blueprint, reusing the same elegant motifs whether it's building a molecule or a supercluster. Yet for all its harmony, math also exposes the limits of our minds. Quantum mechanics dances to equations that defy intuition, where particles exist in multiple states until observed and entanglement laughs at the speed of light. Even Einstein struggled with this, famously insisting, God does not play dice with the universe, but the cosmos doesn't care if its rules make sense to us. Black holes warp spacetime into knots that no human analogy can fully capture, and dark matter's invisible grip reminds us that most of reality operates outside our senses. Here's the humbling truth: we're like ants trying to comprehend Shakespeare. The universe speaks in differential equations and probabilities, while we're wired for stories and cause and effect. But that's what makes the pursuit so thrilling. Every equation we crack, every pattern we decode, is a fleeting glimpse into a logic far grander than our own. As physicist Eugene Wigner marveled, math's unreasonable effectiveness in describing nature isn't just useful, it's a mystery wrapped in a paradox. Why should human-invented numbers map so perfectly to the fabric of reality? Maybe, just maybe, we're not inventing math at all. We're discovering the universe's mother tongue, one imperfect translation at a time. There's a boundary to every horizon, a line beyond which even our most brilliant theories can't peer. Take the Big Bang. We can trace the universe's expansion back to a single, searing moment, but what came before? The question might be meaningless. Time, as we understand it, began with that explosion. Asking what preceded it is like asking what's north of the North Pole. The equations of general relativity simply break down at that point, leaving us staring into a mathematical void. Some theorists speculate about a multiverse, a frothing sea of universes bubbling in and out of existence, while others suggest a cyclical cosmos, endlessly collapsing and reborn. But these are just stories we tell to fill the silence where science for now falls mute. Then there's dark energy, the phantom force accelerating the universe's expansion. We can measure its effects, watch galaxies flee from us faster and faster, but its true nature remains a shadow. Is it a property of space itself, or some unknown field permeating the cosmos? The harder we look, the more it slips through our fingers. This isn't just ignorance, it's a fundamental limit, like trying to hear a symphony through a wall. The universe might be built to keep some secrets. Kurt Gödel saw this pattern everywhere. His incompleteness theorem proved that even in mathematics, there are truths that can't be derived from the system's own rules. No matter how robust your logic, some statements will always be unprovable, like a cosmic game of hide and seek where the rules themselves ensure you'll never find everything. The universe, it seems, follows the same playbook. For every mystery we solve, black holes, quantum entanglement, the origins of life, another takes its place, not because we lack genius, but because reality is designed to outwit us. Yet here's the paradox: the unknowable doesn't frustrate, it enchants. The moment we stop peering into the abyss is the moment we stop being human. Carl Sagan once mused that the universe's greatest gift is its refusal to surrender all its answers, forcing us to keep reaching, dreaming, inventing. The emotional weight of cosmic wonder isn't just awe. It's a kind of love, a fierce and humbling gratitude for the privilege of being here at all, in this sliver of time when we're smart enough to ask the questions, but not yet wise enough to answer them all. Stand under the stars tonight and let that tension wash over you. The darkness isn't empty, it's alive with questions, each one a reminder that the universe isn't a puzzle to be solved, but a story to be lived. And some chapters, it seems, are written in ink we'll never quite decipher. Awe isn't just a feeling, it's a catalyst, rewiring our brains in ways science is only beginning to understand. Studies from Stanford and UC Berkeley reveal that experiences of awe, like standing beneath the Milky Way's shimmering arc, sharpen creativity, deepen humility, and even stretch our perception of time. Participants who spent moments immersed in vast, breathtaking scenes solved complex puzzles faster, acted more generously, and reported feeling smaller in the best possible way, as if the universe had gently recalibrated their place within it. This isn't just poetic metaphor, it's neuroscience. Awe triggers the default mode network, the brain's hub for introspection and empathy, while dialing down activity in the areas responsible for self-focus and anxiety. In essence, wonder literally lifts us out of our own heads. Now, leap back 40,000 years. Picture a shaman in Paleolithic Europe tracing constellations on a cave wall, or an Inca priest aligning temples with the solstice sun. These weren't just rituals, they were humanity's first experiments in cosmic awe, attempts to make meaning of the glittering unknown. Fast forward to today, and the impulse remains unchanged, only the tools have evolved. The Hubble Space Telescope replaces the naked eye. Quantum equations stand in for mythologies, yet the gasp of wonder when we glimpse the pillars of creation mirrors that of our ancestors seeing Orion's belt for the first time. Astrophysicist Janna Levin puts it perfectly: science didn't kill awe, it gave us new lenses to feel it. Here's the beautiful paradox: awe doesn't require a doctorate or a telescope. It's hiding in everyday moments, waiting to be noticed. Try lying on your back in a park after sunset, letting your eyes adjust until the stars emerge one by one like shy fireflies. Download an app like Stellarium to hold up to the sky and suddenly see not just dots, but the swan, the lyre, the distant glow of Andromeda. Visit a planetarium and let the dome wrap around you like a time machine, or simply watch a live stream of the International Space Station as it orbits Earth every 90 minutes, a pinprick of human ingenuity against the black. But the real magic happens when we let awe bridge the gap between knowledge and emotion. When you learn that the light from Saturn's rings took 80 minutes to reach your eyes, or that a single neutron star spins 700 times per second, something shifts. The universe stops being abstract and becomes visceral, a living, breathing entity you're part of. That's the gift of cosmic awe. It doesn't just expand the mind, it softens the heart, reminding us that curiosity and wonder are the truest languages we share across time, culture, and even species. So tonight, step outside, look up, let the sky remind you that you're standing on a rock hurtling through space, and yet here you are, alive at the perfect moment to wonder why. There's something almost sacred about stepping outside on a clear night, tilting your head back, and letting the stars pull you into their silent rhythm. Stargazing isn't just an activity, it's a form of meditation, a chance to trade the noise of daily life for the quiet grandeur of the cosmos. Start simple. Find a spot away from city lights, let your eyes adjust for 15 minutes, and watch as the sky transforms from a handful of stars to a glittering ocean. Notice how your breathing slows, how the weight of the day begins to lift. This isn't just relaxation, it's communion with the universe. For a guided experience, track the International Space Station as it arcs overhead, a bright, steady pinprick moving faster than a jet. NASA Spot the Station app sends alerts when it's visible, turning a casual glance into a connection with humanity's outpost in the void. Or try identifying constellations, those ancient dot-to-dot puzzles etched across the sky. Orion's belt, the Big Dipper, the delicate curve of Scorpius, each one carries stories older than written language. Apps like Sky View or Star Walk act as celestial tour guides, overlaying names and myths onto the stars when you point your phone upward. They're perfect for beginners, transforming confusion into wonder with a single swipe. But stargazing isn't just about recognition, it's about presence. Instead of rushing to name every star, try this. Focus on a single patch of sky and let your vision soften. The longer you look, the more stars emerge, like whispers growing louder in the dark. Notice the colors: the icy blue of Vega, the ruddy glow of Betelgeuse, proof that stars aren't just white dots but suns with personalities. If you're lucky, you might catch a meteor streaking by, a fleeting scratch of light that's gone before your brain can fully register it. These moments are the universe's way of reminding us to pay attention. Now, shift your gaze inward. Artists have long tried to capture the emotional weight of the cosmos, from Van Gogh's swirling Starry Night to the haunting melodies of Holst's The Planets. Their works aren't mere interpretations, they're translations, turning wavelengths and gravity into something the human heart can grasp. Contemporary creators like Thomas Ruff photograph the night sky through flawed lenses, embracing the blur and grain to mirror how memory distorts wonder. Or explore the digital art of NASA's own visualizers who render black holes and nebulae in psychedelic detail, blending science with surreal beauty. The magic lies in the interplay, the way a constellation's myth fuels a painter's brush, or how a physicist's equation inspires a poet's stanza. The cosmos doesn't just belong to telescopes, it's a playground for every curious mind, whether you're sketching the moon's craters in a notebook or composing a song about the loneliness of Pluto. So tonight, step outside. Let the stars remind you that wonder isn't something you find, it's something you practice, one mindful breath at a time. Van Gogh's Starry Night isn't just a painting, it's a fevered dream of the cosmos, swirling with blues and golds so vivid they seem to pulse off the canvas. Look closely and you'll see the artist's brushstrokes mimic the very turbulence of interstellar gas, a phenomenon astronomers now call stellar vortices. It's as if Van Gogh, confined to an asylum in 1889, somehow glimpsed the chaotic beauty of the universe centuries before Hubble's cameras captured it. His work transcends mere observation. It's a scream of emotion translated into celestial fire, proof that art doesn't just depict the cosmos, it feels it. Decades later, Stanley Kubrick's 2001, A Space Odyssey did something equally radical. Instead of relying on flashy special effects, Kubrick collaborated with NASA scientists to render space with eerie realism. The silent spin of spacecraft, the cold glow of Jupiter's horizon, the monolith's perfect geometry echoing the universe's hidden order. That iconic Stargate sequence, a psychedelic plunge into the unknown, blending avant-garde filmmaking with cutting-edge physics. Kubrick understood that space isn't just a setting, it's a character, whispering existential questions about evolution, AI, and humanity's fragile place in the cosmic hierarchy. Now, fast forward to today's digital artists who wield algorithms like paintbrushes. NASA's sonification project transforms telescope data into soundscapes, the haunting hum of a black hole's pressure waves, the chime of distant stars translated into musical notes. Meanwhile, creators like Alvaro Gracia Montoya use generative AI to visualize theoretical physics, rendering warp drives and neutron star collisions as immersive art. These works aren't just pretty pictures, they're bridges, turning abstract equations into experiences that bypass logic and land straight in the gut. What ties these artists together? From Van Gogh's tortured genius to Kubrick's clinical precision to today's code-driven dreamers, is their refusal to let the cosmos remain cold and distant. They remind us that every supernova and spiral galaxy isn't just data, it's a story waiting to be felt. And as we stand on the brink of a new era with James Webb's infrared eyes peeling back the universe's infancy and private companies plotting lunar bases, art will be our compass, helping us navigate not just the how of exploration, but the why. Because the stars aren't just destinations, they're mirrors reflecting back our deepest fears, hopes, and relentless need to reach beyond what we know. The next decade promises to rewrite humanity's relationship with space not as distant observers, but as active participants shaping an interplanetary future. NASA Artemis program aims to land the first woman and person of color on the moon by 2026, but this isn't just a redo of Apollo. The vision is bigger, establishing a sustained lunar presence through the Lunar Gateway, a space station orbiting the moon that will serve as a staging point for deep space missions. Picture astronauts living and working in lunar orbit for months at a time, testing technologies like 3D printed habitats made from moon dust and water ice harvested from shadowed craters. These aren't sci-fi dreams, Lockheed Martin has already built prototype lunar landers, and SpaceX's Starship, designed for Mars, could soon ferry crews between Earth and the Gateway. Meanwhile, down on the lunar surface, robotic prospectors like a Viper rover, will hunt for water ice near the Moon's south pole in 2024. Water isn't just for drinking split into hydrogen and oxygen. It becomes rocket fuel, turning the Moon into a cosmic gas station for missions to Mars and beyond. China's Chang missions and private ventures like Astrobotic's Peregrine lander are joining the rush, marking the start of a new space race where nations and corporations compete not just for prestige, but for resources. But the real game changer might be the Vera Rubin Observatory, set to open its eyes in 2025. Perched atop a Chilean mountain, this telescope will capture the entire southern sky every 3 nights with a 3.2 gigapixel camera, creating a 10-year time lapse of the cosmos. Scientists expect it to spot millions of new asteroids, trace dark matter's invisible web, and potentially find evidence of Planet 9, a hypothetical world lurking at our solar system's edge. Most thrilling, its ability to catch transients, sudden cosmic events like supernova or black hole mergers within hours of ignition, giving astronomers front-row seats to the universe's most violent spectacles. Yet these missions aren't just about discovery, they're forcing us to confront profound questions. If we find microbial life in Mars' subsurface lakes or Enceladus plumes, how will it reshape our sense of uniqueness? Lunar mining raises ethical dilemmas: who owns the Moon's resources, and what happens when corporations stake claims beyond Earth's jurisdiction? Philosophers like Lucian Wakovich warn of space colonialism, where the mistakes of terrestrial history repeat themselves among the stars. Perhaps the deepest shift is psychological. For millennia, we've seen space as a void to cross. Now, we're learning to see it as a home, one that demands new rules, new ethics, and a new vision of what it means to be a spacefaring civilization. The next frontier isn't just a place. It's a mirror showing us who we are and who we might become. Astronauts call it the overview effect, that seismic shift in perspective when you see Earth from space, a fragile blue marble hanging in the void. Chris Hadfield describes it as instant enlightenment, where borders vanish and the petty divisions of politics and nationality dissolve into irrelevance. From orbit, you don't see checkpoints or walls. You see thunderstorms rolling across continents, city lights glowing like neurons in a vast, interconnected brain, and the thin blue ribbon of atmosphere that keeps everything alive. This isn't just awe, it's a reckoning. When Hadfield returned to Earth, he said the experience left him with a profound sense of responsibility, a need to protect the only home we've ever known. That shift in consciousness isn't limited to astronauts. The iconic blue marble photo, snapped by Apollo 17 in 1972, became a rallying cry for the environmental movement. For the first time, humanity saw itself whole, a single organism clinging to a speck of rock in an indifferent cosmos. That image didn't just inspire art and activism, it birthed a new way of thinking. Treaties like the Outer Space Treaty of 1967, signed at the height of the Cold War, declared space the province of all mankind, banning weapons and territorial claims. Even amid geopolitical tensions, nations collaborated on the International Space Station, an orbiting laboratory built by former rivals. Russian rockets ferried American astronauts, Japanese modules docked with European ones. Up there, survival depends on cooperation, but the overview effect isn't just about unity, it's about urgency. Climate change, asteroid threats, pandemics, these are global problems demanding global solutions. Satellites like Copernicus monitor melting ice caps in real time, while missions like DART test our ability to deflect deadly space rocks. the lesson is clear. Whether we're fighting wildfires or launching telescopes, we're all crewmates on spaceship Earth. Yet there's a quiet hope in this cosmic perspective. When the James Webb Space Telescope beams back images of infant galaxies, or Perseverance drills into Martian rock, it's not just one nation's achievement, it's humanity's. Every discovery, every flicker of understanding is a reminder that we're capable of more than conflict. The stars don't care about our borders or ideologies. They simply shine, waiting for us to look up and remember what we could be. So the next time life feels heavy, step outside. Find the moon or Venus or the smudge of the Andromeda galaxy. Let the scale of it all wash over you, not to diminish your struggles, but to expand your sense of possibility. The universe is vast, but it's not indifferent. It's watching, waiting, whispering that we're part of something bigger. And if we can learn to see ourselves as Earthlings first, everything else might just fall into place. We began this journey peering into the void, tracing the arc of starlight back to our own origins, carbon forged in dying suns, oceans brewed in cosmic clouds, consciousness flickering awake on a pale blue dot. Every discovery we've shared, from quantum entanglement to Europa's hidden seas, whispers the same truth. The universe isn't just around us, it is us. The iron in your blood once fueled a supernova's final blaze. The salt on your skin mirrors ancient tides that swept across newborn planets. Even the electricity dancing in your brain right now, letting you ponder these words, is a spark struck from the same forces that spin galaxies. Science and spirituality, so often framed as opposites, converge here in the humblest of revelations. Whether you call it the Big Bang or Genesis, the outcome remains miraculous. Against impossible odds, Stardust learned to wonder about itself. The equations of physics align with the poetry of mystics. Both speak of unity, of connection, of a reality far stranger than we ever imagined. The Dalai Lama once told Carl Sagan that if science disproved reincarnation, he'd abandon the belief. Sagan, in turn, called science informed worship. Both understood that curiosity and reverence aren't rivals. They're twin lenses for beholding the sublime. Now return with me to that iconic pale blue dot. Image Earth as a single pixel, adrift in Saturn's shadow. Sagan's words still pierce the heart. That's here. That's home. In all the cosmos, this fragile sphere is the only place we know cradles life. Not just life, love, music, laughter, the ache of loss, the courage to reach beyond what we know. Every war ever fought, every symphony composed, every child's first step happened on that speck. The universe may be infinite, but this here is our shared inheritance. So let's keep looking up, not to escape Earth, but to understand it better. Let telescopes remind us of our smallness, and quantum physics humble us with its mysteries. But let's also plant our feet firmly on this soil, protecting the only oasis we've found in the cosmic desert. The stars belong to everyone, and the questions they inspire are the truest heirlooms of our species. Now it's your turn. Tell me in the comments, what cosmic wonder leaves you breathless? Is it the thought of black holes bending time, or the possibility of life swimming in Europa's depths? Hit subscribe to join me on the next journey into the unknown, because the universe isn't done surprising us, and neither are we. Until then, keep your eyes on the sky and your heart open to the infinite.